Okay, so hello everyone again. This is lecture 5 part 1 of wave optics. I am Sameer Lavankar. So let's begin our discussion today after completion of coherent and incoherent addition of waves. Today we will be learning a new topic, a new experiment done by prominent scientist Thomas Young, which is based on interference. And what is this Young's experiment? So let's begin our discussion. Okay, so a course outline for you before starting the lecture number 5. So in the previous lectures we have done with the introduction part, what is wave optics, why it is different from the Descartes theory, what is the difference between these two, why was there a need to explain everything using Descartes theory and then using wave theory, and why wave theory is more prominent than the Descartes theory. Then in the next we learnt about the Huygens principle. In Huygens principle, first of all we learnt a new concept called as wavefront. What's a wavefront? And if you have a wavefront, then at some time t is equal to 0, then if you need to find out a wavefront at some time t is equal to t, you can directly find it out using Huygens principle. The third was refraction and the reflection of plane waves using Huygens principle. So using the basic concept of wavefront, we tried to prove the laws of refraction and reflection. So first of all, refraction laws were being published and then reflection laws. In this third point, we also learned about the Snell's law. Moving on, after this completion, we learnt about coherent and incoherent addition of waves. In coherent and incoherent addition of waves, we learnt about the interference concepts, how it is 4I0, either 2I0 or either 0. So coherent is basically about intensity being maximum and incoherent is about intensity being minimum. Today we will be going on to the fifth concept, that is interference of light waves and Young's experiment. So please look over, very beautiful experiment done by Thomas Young. I will try to explain it as slow as I can so that you can understand everything very clearly. So let's move on. So there is interference of light and Young's experiment. So please look. So if we use 2 sodium lamps, so 2 sodium lamps here refers to 2 sodium, so a lamp which emits sodium lines. So if there is a lamp, simple lamp which emits sodium light, then it is known as sodium lamp. Now if we use 2 sodium lamps illuminating 2 pinholes, so these are the pinholes, as the name suggests, it is a hole which is of pin size. So if we use 2 sodium lamps illuminating 2 pinholes, we will not observe any interference fringes. So now let me first of all explain to you what is this interference fringe. So basically let me explain you like this. If this is our screen, on future experiments when I will convey you further, there will be lines shown, either one will be in black color, other will be in white color. So this can be like, I can denote it by W, B, then again W, here B and W. So here W and B denotes the color white and black. So let me just write here. So W is white, B is black. So now what happens is, what does interference fringes mean is, due to the interference of light waves, what happens on the screen, this type of pattern is shown. So this type of pattern of what we can say consecutive chain of the white lines and black lines is called as interference fringe. Why it is called as interference fringe? Because it is produced by the addition of 2 different waves. It can be added coherently or added incoherently. We will understand it in the future slides also, that as it is quite evident, as we have learned in the previous sections, that coherent addition leads to the intensity being maximum, which is equal to 4I0, and similarly for different minimum thing it is always 0. So quite evident, the black color will be visible when it is 0 and the maximum color, or at least 4I0 intensity, will be visible when it is in white color fringe. So quite evident. So till now I just need to explain to you what is interference fringe. So let us move on to the next point now. So if we use 2 sodium lamps illuminating 2 pinholes, I explained to you. So here these are 2 pinholes being talked about. We will not observe any interference fringes. Now next line. This is because the light wave emitted from an ordinary source. So an example of an ordinary source here is used as a sodium lamp, because it only emits one kind of wavelength, undergoes abrupt phase changes in time of the order of 10 to the power minus 10 seconds. So it just says that why does interference happen? Interference happens because first of all an ordinary source is being used, and second it goes abrupt phase changes. I explained to you what's a phase, in times of the order of 10 to the power minus 10 seconds. The change in the phase is very rapid, it is in the power of 10 to the power minus 10 seconds. What does it change? Let us say the phase at some time t is equal to 0 is let us say some psi. and at some t or 10 to the minus 10 second, in the next 10 to the minus 10 seconds only, the phase has been changed to phi dash. So that is being explained here. So because these two conditions are being explained, first of all, a single wavelength line called as sodium line is being used as a source which emits light, and second is that the phase change is very abrupt as in it changes very quickly, very rapidly. The time frame is also given to you, that is 10 to the power minus 10 seconds. Okay, so this point is also been explained. Next, thus the light waves coming out of the two, please make sure that these two light sources are independent sources of light. What does it mean by independent sources of light? Quite evident, as you can see from the diagram on the right side also. Two sodium lamps are being used. That means both lamps are independent. In the future slides or in the subsequent slides, when the experiments were conducted, sometimes only a single source will be used, and then using different types of pinholes, a single source can be used for multiple sources. How it can be used, I will explain you further, but for now, what does two independent sources mean here? Two independent sources means here that two different sodium lamps are being used. Okay, so this point is also explained. So thus this light waves coming out from the two independent sources of light will not have any fixed phase relationship and would be incoherent. So what does this mean? This means that a light wave would come from this, let's say it has a phase of phi, and a light wave would come from this, let's say it has a phase of phi dash. Now it says that phi is never a function of phi dash. What does it mean? That there is no fixed relationship between phase of light which is coming from source S1, and there is no between this and this, the phase of light which is coming from phase light S2 or source S2. Thus the light waves coming out from the two independent sources of light will not have any fixed phase relationship and would be incoherent. Therefore, because there is no fixed phase relationship, from the previous discussions which we held, it is only and only possible when I is 0, and when I is 0 there has to be a fixed phase relationship, because then only that mathematical formulation beings happen and it changes to I0. If there is no fixed phase relationship, therefore it can't be incoherent, hence it is coherent. So when this happens, the intensities of the screens will add up. Quite evident, the intensities only and only goes to 0 when it is incoherent, otherwise in any either case it will add up. It can either add up to 4I0, 2I0 or any different value based on the results. Okay. So because these are happening, because we can't see any interference fringes here, Thomas Young did an experiment. Because there was no interference fringe being formed, further analysis were being done, further research were being done, and finally it was found. So let me first conclude this slide here. So the British physicist Thomas Young used an ingenious technique to log the phases of the waves emanating from source S1 and S2. What was the basis, or what was the main importance of Thomas Young's experiment was, because there were two sources of light. These two sources of light were not being a function of each other, were not dependent on each other, that is, they are independent sources of light. Because they were independent sources of light, the phase difference or the dependence of the phase, let's say I say the phase by psi for phi 1 for source S1 and phi 2 for source S2, there was no relation between this phase and this phase. Because there was no relation, that is, if the change in time, there was the difference between the phases is not always logged or not always exact constant. To change this thing, what he did was, he did a little change in this experiment, which we will understand in subsequent slides. So I explained to you what was the basic need to do the experiment and why were these interference fringes being needed to occur, because as we already explained in the last concept, that there is something called as coherent and incoherent addition of waves. That means whenever there is addition of two waves, there should be a black fringe also occurring if there is incoherent addition. But why are we not following it? Why are we not seeing it? It was a curiosity of the scientist, hence this experiment was being done. So let's move on to the exact experiment now. Okay, so please look over carefully. First of all, let me explain to you. This is a view in which this is one of the cardboard. Let me denote this cardboard by C1, let me denote this cardboard by C2, and this is the screen here. Okay, so what is happening is, as you can see, the pinholes are being denoted by S. So let me write here only. So here S, S1 and S2 are nothing but pinholes. Nothing but pinholes, and this is the screen. So now what is happening is, you can also see interference fringes being formed here. So so in this case, for the what the figure shows about is, there is only one independent source. There is only one independent source. Then in the second cardboard there are two pinholes again denoted by S1 and S2, and finally due to some of the interference being forming, an interference fringe is formed. So I will just explain to you here. Interference fringes are formed. I explained to you in the last slide only what is interference fringe. So this is explanation of the first diagram, and this second diagram I will explain where I will go with the mathematical formulation above. Okay, so this thing is explained. Let me just clear so that everything is clear while explaining. Okay, so let's move on. So he made two pinholes S1 and S2 very close to each other. It is very important to understand that both the pinholes were very close to each other. They were not far, because it is very important when the mathematical formulation will be done that the two pinholes should be very close to each other. Okay, so he made two pinholes S1 and S2 very close to each other on an opaque screen. Please make sure it is an opaque screen. Just to revise you, there are three types of screens. One is known as transparent, second is translucent, and third is opaque. So just to explain to you difference, so what does transparent do? If there is a 100% transparent device, that means the light can pass through it 100%. If it is translucent, then some of the light gets passed through it, some of the light gets absorbed, and in opaque there is no passage of light. So there is no passage of light through it. So that was one of the explanation. Okay, so let's move on again further. So these were illuminated by another pinholes that were in turn lit by a bright source. So quite evident, there is a single bright source, and therefore the light emanating from this source, let us say I make a source here. So this source was being used to brighten up these pinholes. Okay, so these were illuminated by another pinhole that were in turn lit by a brighter source. Light waves spread out from S and fall on both S1 and S2. Quite evident. So the every light source which is coming to source S will go to both S1 and S2, and because a single source is being used, that means the light coming from that source will have a phase which is locked. So this was the basic concept, this was the basic agenda what Thomas Young tried to do when he was trying to make two different cardboards, and then he was trying to what we can say, spread out light from source, that S, through this capital S pinhole, and then going to S1 and S2. Okay, so light waves spread out from S and fall on both S1 and S2. S1 and S2 then behave like two coherent sources, because light waves coming out from S1 and S2 are derived from the same original source, and any abrupt phase change in S will manifest in exactly similar phase changes in the light coming from S1 and S2. So this is the simple explanation I explained to you when I tried to explain why there was different sources in the previous example and why was there a single source in this example. Let me explain to you again, and then I will iterate the statement. So what does it try to say is, let me explain. So let us say this is the bulb, let us say this is a sodium lamp. Let us say this is a sodium lamp here. So what does it happen is, any light source which is moving apart from this point to this point is having let us say there are two lines of rays which is overlapped here. Let us say the line L1, let us say the line L2. After reaching point S, as S1 and S2 are just above and below, so it can be seen here as S1 and S2, let us say this is the source S, this is the source S, this is the pinhole S1, and this is the pinhole S2. S is also a pinhole only, but and the light source is here. Okay, so what is happening is, let us say I explain you this L1 as by this, and I explain you L2 by this. So let us say this is L1 and this is L2. So as the distance are being same for both S2 S1 and for S2 S2, therefore the phase will be same. Because the phase will be same, hence there is no abrupt change in phase with the change in time, hence the phase is locked. So this is only the explanation which is being explained here. So I will explain it again. So S1 and S2 then behave like two coherent sources. In the previous example, S1 and S2 are behaving like incoherent sources, and therefore there was no interference fringe. But because here S1 and S2 are behaving like two coherent sources, hence the further explanation will be done, and then finally we will find out that there is what we can say interference fringes being formed, which is bright and dark color lines. So S1 and S2 then behave like two coherent sources because light waves coming out from S1 and S2. So any light which comes from this let us say are denoted by L3 and L4, a single ray of line are denoting it by L3 and L4, there will be huge infinite light rays coming from these sources S1 and S2 are derived from the same original source. So, this is the same original source being talked about, this is the same original source, this is the same original source. Okay, and any abrupt phase change in S will manifest in exactly similar phase changes in the light coming from S1 and S2. So, what does it try to say is, let us say at some what we can say at some time, let me write in the right corner here, let us say at some time t is equal to 0, the phase of that sodium lamp was phi. So, at any time t is equal to t, I mean we do not have to differ it by c, we can directly generalize it, but some time t is equal to t, then at some time t is equal to t, always that let us say the change in the phase was phi 1, then the phase will be for both light coming from S1 and S2 will be phi dash only. Hence, the phase is logged and hence we do not have to refer to the changes in phase and the mathematical formulation is easier apart. Okay, so concluding it, so thus the two sources S1 and S2 will be logged in phase, quite evident it is logged in phase, that is they will be coherent. So, if the phases are logged, that means the two sources of light are coherent, like the two vibrating needle in a water wave example. So, this is the example which I explained you using when the concepts of coherent and incoherent addition of waves were being explained apart. So, there were two needles and then the waves were coming like this. So, this is a similar example here. Okay, so let us move on to the next slide now. Okay, thus spherical waves emanating from S1 and S2 will produce interference fringes on the screen GG dash. So, this is the screen GG dash. So, this is the screen, if I write it like this, and this is the screen GG dash here. So, thus spherical waves emanating from S1 and S2 will produce interference fringes on the screen GG dash as shown in figure B. This is the figure being talked about here. The positions of maximum and minimum intensities can be calculated by using the analysis given in the last section, where for an arbitrary point P. So, this is the arbitrary point P for which we need to find out if it will have a maximum intensity or it will have a minimum intensity. So, the positions of maximum and minimum intensities can be calculated by using the analysis given in the last section, where for an arbitrary point P on the line GG dash to correspond to a maximum we must have. So, please make sure that if we need to find out if the point P will have a maximum or minimum intensity, we just need to calculate if it will have a coherent addition there or an incoherent addition there. So, what does we need to find out? If we can calculate if S2P minus S1P is n lambda, then we can find out that if it is coherent or incoherent. So, this further analysis, this mathematical formulation I will explain to you in the next part of this lecture only. For now, let me conclude it. So, in this lecture what we find it out? First of all, when the initial experiment was being done, there were two sources of light denoted by S1 and S2. Please make sure sodium lamp is being used, that means a single wavelength light is being used, and because of the two sources of light, when the addition was being done either coherently or incoherently, the interference fringes was not found. Why it was not found? Because the phase changes in the light sources was very high. The abrupt changes in light was being happening. Because this abrupt changes, the phases can't be logged and hence the experiment cannot be performed. What does Thomas Young tried to deduce from this thing was, he used only a single source of light and hence this single source of light called as sodium lamp was being used, and after the sodium lamp was being used, this phases was being logged. What does it explain? What does it know by phases being logged? That is, with the change in time, if the phase is changed from phi to phi dash, then for these lights emanating from S1 and S2, the phases will be same, which is phi dash only. Hence, interference fringes were being found. How it was found? Why is there? What is the formula associated with it? Everything is basically concept linked to coherent and incoherent addition only. Whenever in the any point, anything which is explained in this point P, either it will have a coherent addition or it will have an incoherent addition. So, if it has n lambda, then it is a coherent addition. If it is having n plus 1 by 2 into lambda, then it is incoherent addition. Similarly, as we know that for incoherent addition, the intensity will be 0. For coherent addition, it will be 4 I naught or 2 I naught. So, that means we can directly find out if we know the mathematical distance of that point P from the initial portion of S or S1 or S2. So, I will explain you this mathematical formulation in the next class. For today, thank you.